All right, here we are. Let's talk a little bit about experimental design. So what I'd like to do today is answer a research question. And we're going to use this simulation that was on the screen in order to try to answer that question. So we'll come back to that simulation in a moment. Let's do this. Let's call this predation CER. If you would like to do this in a Google Doc, if you're taking notes that way, that's fine. Instead, if you would rather just write it into your notebook, that's fine too. So here's my research question. What effect does predation have on the population abundance of balanus barnacles? Question mark. End quotation mark. All right, so take a look here. Let's annotate this research question just a little bit, right? A good research question is interested or curious about the relationship between two variables, right? And when we design experiments, those variables have names. This is one of the variables. This is called the independent variable. Independent variable. Make sure I spell it right. What's the independent variable? Let's define it. This is the variable. What the researcher, that's you, that's the student, that's the scientist, changes or manipulates. All right. So in an experiment, we're interested in predation and what effect that has on the population abundance of a certain type of barnacle. And so we're going to set up this test, right? Think about this. We're going to collect data 2 times. We're going to have a trial without predation, and we'll have a trial with predation. And then we'll be able to compare results. And what are we comparing? That's that other variable in our research question. Right here, we're going to take a look at the population abundance of those balanus barnacles with predation and without predation. And this variable in experimental design is called the dependent variable. Let's define that. That is what changes as a result of the change or manipulation of the independent variable. All right, it's the effect. It's what happens after you have applied the independent variable, right? So we're going to look to see what predation has effect on a population of balanus barnacles. Now, before we start, oftentimes in school, what we want to do is we want to just jump right into it and start working with the simulation. But it's really important that we take some steps before we do the fun stuff, right? Which is to collect the data. We need to have something that we can collect our data into. And so it's really important for us to draw out a data table that will house our evidence. If we're going to be writing CER statements, claims, evidence, reasoning statements, and include the evidence, then we need to make sure that we're getting that evidence and organizing it in a way that will be easy to access later on. So how about we say here, these are the trials, and then this is going to be, we'll call it the local abundance, how many barnacles there are, right? And let's do this. We're going to say, we'll do this 2 times, because trial 1, let's do this. Trial 1 we'll call the control group. Let's just make sure that we understand that the control group is really important in experimental design too. The control group does not receive the independent variable. In this case, no predation. So I'm going to put that into a parenthetical for us. The control group and the experimental group look exactly the same. So all of the factors within both the control group and the experimental group are the same, except for the independent variable. So we're going to say with predation. Right? Think about it. If everything, all factors, and I'll talk about what those factors could be in a moment, but if all factors between these two groups are the same, except for the addition of the independent variable, then we can start to make claims then that that independent variable is responsible for a change that we see here, if there is a change. So, right? If there isn't a change, then we'd say, well, hey, maybe it doesn't have an effect on it. But let's take a look at it with our simulation. So I'm going to come over here. So right away, like, right now I see the water is moving up. This intertidal zone is where the barnacles will tend to accumulate here. Notice that the predator down here, this little Thais snail, is going to stay in the water most of the time, or actually the whole time. So it's the barnacles then that can be submerged, or they can be out of water too as the tide goes down, as long as it's not too long. Otherwise they die. But let's do this. I'm noticing here that there's two different species of barnacles on our rock, and hey, we're not introducing that variable in here. We're looking to see what effect predation has on balenous barnacles, not balenous and the other type, the thamellus type. So I pushed pause on my simulation. I'm going to remove all of the barnacles. In fact, I want to remove the predator too. So those little snails right here. So we'll go from 3 to 2 to 1 to 0. All right, think about it for a moment. We don't want to have predation in our system, and so I've removed predation entirely from our system. And take a look here too. I can increase or decrease the amount of larvae per milliliter that is available to kind of sit on top of or attach itself to these rocks. And so right now there's thamellus, and so I'm going to remove these, so all the way down to 0. I don't want to have competition between two barnacles. I only want to look at predation. And how about we ramp this up here? On the other side is kind of this data table, and this is the number here that we care about, the local abundance, the total number of balenous barnacles that are on the rock at the time. I'm going to click reset, and what we'll do is we're going to let this experiment run for 10 days. So once I push play, the process starts. Actually, we're going to kind of speed it up too, so I can make it go faster. There we go. Those orange balenous barnacles are starting to establish themselves on the rock, and I come over here to the data collection. We're increasing their numbers, their abundance, their population here on this rock. Let's do this for 10 days. 8, 9, and 10. How about I let the water go up once and then back down? Okay, we'll push pause. Notice there was no predation at all, and the local abundance of the balenous barnacles on this rock was 240. Okay, let's come back over here. I'm going to click reset, and we'll go over here. Take a look. Hey, because we started off the first trial with no barnacles on the rock, I'm going to remove all of these. We want to keep every factor the same between our different trials, right? If we did our control group without balenous barnacles on the rock, then we want to have our experimental group without them too, right? And kind of going further, I'm not going to change the sea level, I'm not going to change the tide, I'm not going to incorporate a different species of barnacle. The only thing that I'm going to do now is to include or increase predation, because we're interested to see what effect predation has on the total number of barnacles on that rock, well, after 10 days, right? So I got to make sure that I run the simulation for 10 days again. And we're off. Notice that the Thais snail, the predator snail, is staying within the water. So, right, think about the niche concept here, right? let's let that go up and then down. Okay. Think about the niche, right? So the niche is the role, the job, the function of the species, and in this case, it's one of its functions is to be food for the tie predator, just as much as the niche for the tie predator is to consume and kind of control that population number of balenus barnacles. Notice too that it kind of like prior to this, without predation, all of the rock face where the barnacles could be, including the areas submerged entirely in the ocean water, was filled up. Notice now that that area is gone, and the reason for that is the predations. And take a look here, the local abundance. So we decreased. We went from 240 to 128. All right. So let's do this now. This is our raw data, and when we write out our claims, evidence, reasoning statements, our CER statements, absolutely include the raw data within your evidence segment or section of your claim that you're creating. But what I like to do too is process these numbers and calculate like a statistical means that we can use to bolster our claims. We can use that in our reasoning section too. So what we'll do is we're going to calculate, oftentimes you can calculate percent difference. If you ever have two numbers, 240 and 128, you're going to want to determine the percent difference between those two variables and absolutely include that number in our claim, right? So how you do this is you take the original number and you subtract out or take away the new number. The new number, right? This is our original number, 240, and then we then after the fact, right? That's our new number there. We're going to divide out by the original number. I want to put these in absolute value lines here because I don't want to have to deal with a negative number. Instead of having a negative number, we could just rather say decrease or increase or stayed constant, no change within our sentence that we write out, right? So I got rid of the negative numbers here. Hey, I like to multiply this number by 100 so that we can move the decimal point over 2 to the right, right? We're turning this decimal number into a percentage. In fact, what we'll do is we'll tack on a percent sign. I put that there only to remind us to make sure that we add that percent sign back onto our final answer, right? I do not want you to write or type that percent sign into your calculator. Our numbers will be wrong. So let's do this. Let's plug in the numbers. 240 minus 128 over 240 multiplied by 100. All right. Did you know that Google has a calculator? You can just type the numbers directly into the Omnibar, which is the area where you type in our links, right? So we're going to type in 240 minus 128, and bam, it's going to pull up a scientific calculator. The difference between those two numbers, 112. Let's divide out. 46.666. We're going to multiply this by 100. Notice I'm not typing in the percent sign. Don't do that, right? Just 100. That's going to move that decimal point over 2 to the right, and then we can tack on the percent sign on our paper. So that's 46.7% decrease. And I always want to add, make sure that I add that directional word there that will describe what's happening with that statistic, right? We're decreasing the population by how much? Well, 46.7%. All right, what I'd like to do is write out a claims, evidence, reasoning statement, and you're going to turn this in on our Canvas class. So what are each of the components? What are my expectations for at least this one? Well, here's what I want. I want your claim to answer the question. Be directional. Be directional. And that means, again, tell me about, it's an increase, it's a decrease, it's a negative, it's a positive correlation. or it's constant or stayed the same, right? For our claim, it would be, well, what's the question? What effect does predation have on the population abundance of Balenus barnacles? Predation decreases the abundance of Balenus barnacles. Evidence. Tell me about the raw data and how you collected it. Include the raw data in here, right? Raw data. I'm talking about if you don't have the word or the numbers 240 and 128 in your CER statement, you're not giving me the full picture of what went down, right? So, for example, our evidence statement could be, well, we set up two different groups and we found that without predation, there were 240 Balenus barnacles, and after predation was added, there were 128 barnacles. And then our reasoning is the justification, right? And this is where we can include that statistical measure. I like to write out, I know this because, all right, and include a stat if possible. This is also the area where you can explain some of the science too. But for ours, we can simply say that I know this because there was a 46.7% decrease between the two populations with or without predation. All right, so always include that statistical measure. And then incorporate that or write that out into the post on Canvas, and we'll go from there. Thank you very much. I hope that this was helpful.